Whether you want to use it yourself or not is another question. All right, the string class was designed to take the place of C strings and allow you to manipulate string values without having to worry so much about how they're physically implemented. And it can do a lot of things that are difficult to do with C string and using fairly straightforward syntax. So, for example, the plus operator allows us to concatenate strings together. We can use the assignment operator to store a new value in a string without worrying how big it is or what was in the string before. And we can initialize a string either using our equal sign and a C string in quotes, or we can use parentheses with a C string inside them. Since we still are stuck with C strings for in the real world, at least in some places, we need to know how to deal with that. But for everyday use, it's pretty easy just to make a string, set it to a value, concatenate it with other strings, and use it pretty much like we do any other variable. When we're doing input, it's exactly the same limitations that we had with our other, or I say exactly, it's just some of the same limitations that we have with our other classes. Our input is going to stop when we encounter a white space. Output works just fine. It's going to output whatever we have in our string. If we want to get everything in a line, we have a getLine function. However, it's going to be different just because string was an early class that didn't get standardized. So there's a standalone getLine that takes an input stream and a string that we use to get all the data up to a new line character. And we can use that either with standard input or with a file stream. Again, we have some more self-test exercises. Page 477. Mr. Gear, number 15. Consider the following code. We've got two strings, S1 and S2. Sorry, go ahead.
A asterisk string N1 or in the output.
Okay. So since we're using the extraction operation, it's going to stop when it gets to white space. So S1 is going to have A, and S2 is going to have string. Number 16, Mr. Rahim.
A string is enjoyed forever. And an output.
Okay. This time we're using the getLine function, which is not going to stop on white space. It's only going to stop on a new line. So it's going to read the entire line of input and put it in the string S. A couple more things that we can do with getLine. It can take a third argument that will use a different character other than new line to stop. And there's this weird thing where if you use it with an extraction operation, it returns a reference to its input stream. So that actually works as if we had CN extracted into S2. You might run across that someday, but so just in case you did, now you know. Again, you want to be careful mixing extraction with getLine, because getLine is going to stop at a new line and leave you there. So the next thing you're going to come across, or the extraction is going to stop at a new line or white space. The next thing you're going to come across is going to be whatever white space was left off by the extraction operation. So getLine may find that the very next thing is a new line character. So there's another function that we can use called the ignore function that will ignore some number of characters or until it gets to a specific character. On page 480, they've used that with 1,000 and new line. So we'll ignore either 1,000 characters or until it gets to a new line character. And then will be placed past the new line character. More things we can do with strings. We can pretend that it's a character array. So we can refer to individual elements of the string as if they were characters in a character array. And we can do that either with square brackets, like we use with an array, or a function called at. The advantage of using the at function is that it will tell you if you've supplied an illegal index to it. Or maybe not so much tell you as generate runtime error, but in either case, it will be more obvious what's happening. And page 482 and 483 have some of the members of the string class. Again, Appendix 4 is a good reference. The string functions are on page 1023. So we have constructors, accessors. We'll learn more about those when we study classes. We have the substring function that allows us to extract, starting at a particular position, some length of data from a string. The length function returns the length of the string. We can assign or concatenate. We can determine if a string is empty. Insert one string into another. Remove sections of a string. We can use the traditional comparison operators that return Boolean values. Or there are several flavors of find that allow us to find strings inside other strings. And display 8.8 is a palindrome function. That function is going to be fairly useful for you when you're working on your next programming assignment, because it has sample code using various functions. So everybody know what a palindrome is? If you don't know what a palindrome is, it's a phrase that reads the same forward and backward. One of the more well-known examples is Madam, I'm Adam. If you take out the punctuation and spaces and make everything lowercase, it reads the same forward and backward. They've got some more examples on page 484. But basically, the way they figure out if a phrase is a palindrome is in the isPal function. The isPal function really is probably a little over-engineered, but it does illustrate some interesting points. So they don't change the original string. They've got the const there. They've got a string called punct that has all the punctuation characters in it. So the first thing they do is make lower. Make lower is just going to loop through the string one character at a time, converting each character to its lowercase equivalent. Then they call remove punct. Remove punct is going to take that punctuation string and for each character of the original string, it's going to see if it can find that character in the punctuation string. And if it does, it's going to ignore it and not copy it into the new.
So on that one, because for the assignment,
Yes?
we're going to have to do something similar to that because we need to recognize if it's white space or punctuation to count the words.
Right.
Does it recognize it as white space, or can you just make it do a logic that would recognize the punctuation as white space?
Well, one way you could do it would be to look specifically whether it's a character or not. Since I said you should also look for numbers, so you would say is alpha is digit, or you could have a set of characters you want to ignore. When we look at the assignment, we'll talk a little bit more about that. So basically, by ignoring everything they find in the punctuation string, they have a shorter string. They end up with a shorter string that doesn't have any punctuation in it. And then they call reverse to go through the string, copying it to a new string that is in the opposite order. And finally, they do an equal compare on the lower string and its reverse. If that returns true, meaning they're equal to each other, then we did in fact have a palindrome. Another thing that's interesting when dealing with strings and C strings is it's a little difficult to get from one to the other. So actually, to get from a string to a C string is fairly easy. We can just say string equals C string. But to get from a C string to a string is a little more difficult. You see they try to do it on page 488. So we have a C string and a string variable. String variable equals a C string works just fine. A C string equals string variable does not work. We also cannot do a string copy with a C string and string variable because string variable is not a character array like string copy is expecting. Luckily, there is a string member function called cstring that returns a C string. And we can use that C string that gets returned by that function with the string copy function to copy the value in a string into a C string. Doesn't mean that you can just put it in with an equal sign, because that's still illegal for a C string. We can't assign a new value to a C string. We have to use string copy and the C string function together in order to get that. There are also some new functions in the 11 standard of C++ that allow us to convert from strings to numbers and back. Before version 11, there was a lot of complicated rigmarole that you had to go through. But now we have the S2I function, which allows us to convert numeric strings to integers. The S to D function that allows us to convert numeric strings to doubles. And the toString function, which allows us to convert from numbers to string values. So it's a lot easier than it used to be to get to convert back and forth between strings and numbers. One more data type before we finish chapter 8, vectors. A vector is what's called a template class, which is why it has the unusual notation it does. A vector has its base type inside angle brackets. And basically, well, if you take the advanced C++ course, you'll learn that template classes are written one time and then they work for whatever value you or whatever type you include as the template type. So a vector is supposed to be able to use any kind of value. Basically, it's a way to have the equivalent of an array that can grow and shrink. Index starts with 0, just like an array. And we can set a particular element using square brackets. Set or retrieve a particular element using square brackets, like an array. You have to be a little more careful about indices with a vector because you don't automatically get any elements. So we have a size function that tells us how many elements are already have been created in this vector, and we can iterate through them that way. But in order to create new elements, you have to do some things a little differently. One way is to use the pushback function, which will add a new element to the vector and give it the value of whatever argument we pass to it. But if you try to refer to an element of a vector that's not been created, you're going to have a problem just like you would an illegal index in an array. In addition to size and pushback, there are a couple of other functions that deal with the capacity of with the memory allocation for an array. An array has a capacity, which is basically how many elements it could hold based on how much memory has already been allocated for it. So you can retrieve the capacity with the capacity function. You can also change the capacity directly using the reserve function, presuming that you tell it to reserve a larger number of elements than it already has. Or you can flat out resize the array, telling it to have a particular number of elements, and it will make the vector that size. If it was larger than that, the extra elements will be thrown away. If it was smaller than that, extra elements will be allocated, and they'll just have whatever value, garbage value was in memory at that point. So typically what is done is, if you need to manage the memory being held onto by a vector, you would reserve however many elements that you anticipate needing. And then if you are through with those elements and you want to make your vector smaller, you would resize it to a smaller size. All right, Ms. Hernandez, on page 494. Number 19, is that program legal? And if so, what would it output?
Zero. One, two, three, 4, 5, 6, 7, 8, 9.
All right, let's take a look at it. So they've actually done something a little different. And if you read this chapter, you may already know what this means, but this number in parentheses, when we're declaring a vector, tells us how big to make the vector to begin with. It's basically resizing it to that size to begin with. This loop is going to initialize all the values. So it's size 10. It's going to initialize it to the values 0 through 9. We then declare another vector called copy, and we copy v into copy. So copy basically is going to get its own memory and all of the values out of vector v. We then set element 0 of vector v to the value 42. And you said the values that come out will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is correct, because since we're dealing with copy and not v, copy didn't get changed by this statement. So the original values are still there. All right, well, let's take a look at our assignment. Assignment 8, word count, project 2 on page 499. Write a program that will read in a line of text and output the number of words in the line, the number of occurrences of each letter. And they say to define a word to be any string of letters delimited at each end by white space, period, comma, or the beginning or end of the line. And that the input is going to be all letters, white space, commas, and periods. I say they may also be digits, and you might allow the processing of other punctuation. If you do allow other punctuation, make single quotes and hyphens not start a new word, but other punctuation does start a new word. So they have a sample input, I say hi, which would produce the sample output, 3 words, 1 A, 1 H, 2 I, 1 S, and 1 Y. And here's our grading criteria. I'm going to say we'll probably want to use string for this. And although you could put all of the code inline and make it presumably more efficient, let's say we are more interested in having reusable functions. What functions can you see that would be useful?
We need to do something with the punctuation.
All right.
But whenever I read it, I was reading it out the book. I didn't get the, you want to account for other punctuation doing other things.
Yes?
This may be a more complicated function.
Well, you can certainly start with
Change the all one case.
I mean, we could do at all one case would make it easier to count letters. And as far as counting letters, what kind of information are we going to need for that? So it might be useful at this point just to say how would I do this if I was doing it by hand? I say hi. If I was doing it by hand, how would I count the words? How would I count each letter?
You just count the words. And then after you count the words, you can.
And when you say count the words, what are you actually doing?
Counting white spaces.
I figure out where each word starts and where each word ends. I know that the start of the line means something. And here we have a letter, and then there's white space up, and so I'm going to count that as a word. So some more white space. Oh, and there's another letter. That's the start of a word. Letter, letter, letter. Oh, more white space. That's the end of a word. White space. Here's a letter. That's the start of a word. Oh, and here's some punctuation. That's the end of this word, because period stops a word. There's no more letters, so I have 3 words. 1, 2, 3. And how would I count letter frequency? Mr. Rahim, any idea? If I was doing it by hand, how would I do it?
You would count it per letter, so would it be 1, 2, 3? Or word?
Well, it wants me to show it like in the example. Let's go back to the example. One A, 1H, 2I, 1S, 1Y. I would say, if I was doing it, I would say, oh, there's a letter. It's the I. So I've got 1 I. And here's a space. I'm not counting those. Here's an S. I have 1 S. And here's an A. Oh, these are going to need to be in alphabetical order, right? So there's 1 A and a Y. There's 1 Y. Space, I'm not counting those. H. Oh, H needs to go in between. 1 H, and here's an I. Oh, I already got I, so I'm going to add 1 to that. What does that look like in programming terms? Mr. Hernandez, any ideas? Mr. Gear?
We need to make an array.
All right, how about an array? Or maybe call it letters. And it's got a box for each letter of the alphabet. uh, except I'm counting them, so I want it to be integers, right? 26, because there's 26 letters in the alphabet. And now when I find an A, I just add 1 to the A element, the 0 element. And we can figure out the index just like we did in our seats problem, right? A is going to be 0.
Semicolon, where A is less than 26. Semicolon, A.
Well,
Oh, you're saying A is going to be 0.
A is going to be 0. And Z will be 25, right? And we already know that 2 lower gives us the decimal of the ASCII code. And if we subtract the decimal for A, that will give us, as long as it is alpha, we can use the is alpha function. So that means we'll probably need a array six letters. We need to initialize them all to 0. And I'm inviting one of my rules. Which rule is it? I already said we were going to need a string. I'm just going to give it an initial value first because I don't want to do too much of your work for you. it may be that you'll think of a better way to do this. And if you do, I want you to use it instead of mine. So, but if we're going to count letters, and we just go through every character in our string, figure out what letter it is, and add one to that letter, right? How do we do that, Mr. Haim? Have any idea how we would go? All we're doing when we're counting letters is we're looking at each letter in our string and we're saying, is that a letter that I need to count? If it is, figure out which letter it is, like this. Add 1 to the number that we've counted for that letter, and then go on to the next letter. What does that sound like? Ms. Hernandez? Mr. Gear? If you're going through a number of things one at a time, what does that sound like? Sorry? Well, we're incrementing. We're looping, aren't we? What's that going to do? Isn't it going to iterate through the string one letter at a time, starting at the beginning of the string? So what did we say we were going to do if we were figuring this out manually? I've already got the part where I go through one letter at a time. What do I do for each letter?
Increment the letter count.
Okay, what letter count are we incrementing?
The array of letters.
Okay, letters.
So letters I, array sign I. And array sign equals 0.
Okay, so we already set them to 0. That's what this code did. So what are we trying to do here?
Add one there.
And what is I in this case?
It's whatever the letter is.
It's whatever the letter is.
Position in the array.
It's the position in the string. So the first letter in the string is not necessarily going to be A, is it? Letters is A through Z, right? Isn't that what we said? So I is probably not the right index here. What would be the right index? If we were trying to increment the number of H's, no, the number of I's in the sentence I say hi, what would be the right index? Eight, right? How do we get to 8 from H or from I? Did I write there? Yeah, from I, how do we get to 8? What is this about?
I equals 8, right?
Well,
You do this.
we know the letter I is equal to 8 in our indexing scheme because the letter A is equal to 0, right? If I say that, this letter equals to lower string at I, and we're on the first letter of that string, I say hi, which is I, what value am I going to get? Let's look up to lower in Appendix 4. Character functions, page 1022. To lower returns the lowercase version of its argument as an integer. So it's going to return the code that means I. And that code, what did I tell you that code was? The ASCII code, right? Page 1018 has the ASCII codes. A lowercase I is 105. How does that help us? What's the lowercase a code?
97.
What's the difference between 105 and 97?
8.
8. So
Subtract 97.
if we subtract 97, except I don't want to say 97 because what if we change to Ipsidic? the two lower value for A, which we know is 97, but we don't care. We just know A needs to be the equivalent of 0. If this one was A and we subtract A from it, it should give me 0. Since this one is I, if we subtract A from it, it'll give me 8. So what does this mean now? That's the element number 8, which corresponds to the letter I. Now if I increment it, we're adding 1 to the number of i's that we found. Does that make sense? Does everybody understand that? So you're going to need to put in some more code, because first of all, our letters array is only big enough to hold the letters from A to Z. And we need to make sure that we're not trying to process stuff that isn't letters from A to Z. You're also going to have to figure out how to count the words. But I'll give you one more. Let's see what happens if we try to run this. Didn't like me at all, did it? Oh, because I didn't call the function. I've got to call my function. Let's try again. All right, so I didn't limit it to the letters of the alphabet this time, which could make things messy if you don't. But you'll notice I made it 256. That's the extended ASCII character set. 126 is the basic ASCII character set, which would probably be enough. And it counted 2 spaces, 1 period, 1 A, 1 H, 2 I's, 1 S, and 1 Y. Does anybody think they understand what we're doing yet? Maybe? Once I've counted the letters and I put the counts in the letter array, if the count is greater than 0, I want to output it. And you'll notice since I didn't limit it to the letters of the alphabet, it used the entire ASCII character set on page 1018. Although they don't put them all in here, they start with space. This code, as it's written now, will count any letter you throw at it. Including colon and greater than and all of those. The problem just wants A through Z. All right, well, it's 8 o'clock. So you got about 15 more minutes if you would like to start working on that here. Otherwise, it will be due next week. If you have any questions in the meantime, send me an email, include your code, and I'll try to help you. Any general questions? All right, that's the end of our lecture for tonight, and